All right.
Good morning, everyone. Today we are excited to present our group project proposal. It's the name of our project is Community Engagement through Robotics Education. My name is Mohammad Akib Hamid, and I am working alongside my teammate Ademi Adetunzi DOLAPO. Our goal is to take the complex math and logic of robotics and turn it into something everyone in our community can understand. So, for our target audience, uh, robotics should not be a black box that only experts understand. To break down these barriers, we are targeting two specific groups: junior learners, who are students aged between 13 to 15 who are just starting to explore technology. And the second group is the professional tier, undergraduate students and international professionals who want to see the advanced engineering behind the machines. So our project theme is the evolution of robot navigation. Most people see a robot moves and think it's like magic, but it's actually a mix of sensing, control, and decision making. We believe that by showing how a robot evolves from simply following a line to intelligently mapping a route, we can make this difficult concept much easier to digest from for any learners. So, as a background, why are we doing this? Currently, there is a gap between high-level robotics research and public understanding. Our project serves as a bridge, translating technical jargons into clear, accessible educational materials. So actually, we want to show how a simple line following uses the same basic logic that powers a high-tech vacuum cleaner. We have two main goals for this project. First is we need to prove we understand the core concept like sensors, kinematics, and path planning. And the second is communication. It is one thing to solve an equation, but it is another to explain it to a 14 years old. So we are aiming to master the art of technical storytelling. For that, we have our we have divided our main objective and goals into these two parts. Our learning part is demonstrate mastery of core robotic concepts and mainly translating the knowledge into accessible explanation so that people of those two category can understand easy. So selected topics. To keep our project focused, we have selected only two key topics. Topic 1 is line following logic. This is the beginner stage, focusing on basic sensors and how a robot reacts to what it sees right in front of it. And topic 2 is robot vacuum navigation. This is the advanced stage involving mapping, path planning, and where the robot has to think ahead. Now for our deliverables of the project, I will ask my friend to present from the next slide. Thank you.
Okay, for the delivery deliverables. The videos, we're gonna make a video series details just as required in the assignment deliverables. So video one, we're going to talk about the robot that follows the path. We're going to show how the robot follow the path, and
Ademi,
we'll
your microphone is off. Cannot hear anything.
sorry about that. So the deliverables, it's as required as it is on the assignment. So the first video we're going to do is the robot that follows the path, which is going to be a clear explanations of how robot follow the path, just as my fellow friend said just now, the sensing of robot and sensors. So this will give a clear understanding to age group between 13 to 18 years old. And for the second video, we're gonna do more on advanced, which is the robot that knows the map. How did the robot able to know the maps, and will give a clear explanations. So this will be very understandable for undergraduate and a professional. So it's gonna be pretty advanced. Alright, so yeah. So the engagement that we're going to be using is mostly going to be HTML and JavaScript platform. So it's going to act as our digital exhibit for our content. And for the interactive demo as well, we're going to mostly use JavaScript based path, as this is one of the most easiest way to explain and to execute this project. And for the planning simulator, users gonna place obstacles on a grid, and the system visualize the robot calculating the path. So we're gonna um, do something that is gonna be relatable with how the robot's gonna know how to calculate the path. If there is an blocked path, where is it gonna go and how is it gonna move around. So last but not least is our conclusions, which is this project is a fundamental about translations, which means taking complex robotics concept and adapting them for two entirely different audience, as we said just now, one for the high school and one for a professional or undergraduate student as well. So as this slide shows, our delivery works together to achieve the core learning goals. So both ways, core learning goals for us and also for our target audience as well. So that's all from us. Thank you very much.